we should all just be happy that we have the ability to run these incredibly bloated and slow programs. Welcome back to Perpetual Jank Machine, the only podcast that ensures that we get the maximum value out of our code closets. I'm John.
I'm Miles.
Miles, how many layers does your software have?
Layers?
Of code, of libraries, of VMs. What are you running on?
Personally, in my personal projects, I tend to just keep it as simple as possible. I try to avoid using libraries. I guess that's not as simple as possible. But that's mainly because I like the learning factor. I enjoy the aspect of learning about the different pieces. Turns out math is hard and writing a math library is even harder. But it can be fun to learn about that stuff. It also cannot be fun, but it's up to you. So I usually mine's I don't know, monolithic. Not really, but I usually just keep it all and as one little thing as I can.
And you like to use the faster languages too, like C and C++. So I'm assuming those run relatively quickly, relatively close to the metal.
Yeah, if someone else writes the code. Yeah, definitely.
If someone else writes the code. I'm kind of the opposite. I kind of like things with garbage collectors, but I feel like as a craft, software engineers have really taken every inch of performance that we can get, and we've kind of made it such that every single time we get another 20% boost in the average consumer's performance, we'll just take that right back and slap another layer on top of it to give us another maybe 5%, 5% quality of life. And then, your buttons are still going to take 200 milliseconds to respond, because that's about what your average user will bear, regardless of how fast it is.
Yeah, that is one way of going about it. I definitely feel that. Yeah, I guess it really depends on how you think people value performance and what you define performance as. I guess that's high performant for the programmer.
Yeah, I guess it kind of depends on what you need, right? If it's a big government website that you're only going to go to once a year, maybe the standard of performance is not that high.
It definitely isn't, but that might not be.
There are some good government websites out there. I will concede that. There's some really high quality government websites out there.
What? Like the Department of Graphic Design? Who's got a good...
In some particular areas, state and national government websites are actually pretty good. If you're applying for, I think, a ballot, the website's pretty good. The health insurance website is pretty good. I think a lot of government websites they're not disgusting. I've seen disgusting websites,
yeah.
And I think that actually private entities who are not website focused nowadays actually have worse websites than the government.
I agree with that. Yeah. Because at least the government's large enough that people are oh, yeah, okay, we can definitely work with this. You're the government, so we literally have to work with this. So let's try to make it work at least okay. Whereas big entities, they're okay, literally only we are using this, so we can do whatever the hell we want.
Yeah, I tried to buy tickets for a certain venue recently, and their website was so unperformant. It took, I think, a minute to generate the QR code that I would have to scan to get in. So in that time, I had thought that the website just was never going to respond to me. So I went back and then I opened it up again just to see if kicking off the loading process would actually make it work again. However, when I got my tickets, there was another link that I had to click to get a parking pass for that venue. And I think this is because I opened it up twice. The parking pass then threw an error, and there was nothing I could do about that.
Well, that was on purpose. They made it bad on purpose to deter scalpers. If you want that ticket, you better want it.
The worst part is that this was a relatively new startup's webpage. They were not a well-established company that existed in the 1990s and has a mainframe with stuff written in Pascal. This is something that's somewhat recent. And it got me thinking, maybe performance is not just a measure of your newness or your organizational rigor or the number of layers you use. Maybe it's just whatever the consumer will bear.
Now you're bringing up some good points. I guess typically higher stake things usually are more performant, and lower stake things are just the bottom of the barrel. You want a square? Well, guess what? That's going to take 30 minutes to load. It's red square.
And I guess performance in that sense is reflective of the society that you live in, right? If you live in a capitalist society and there is a market reason to be faster, see high frequency trading, then you're going to pay Intel for some classified 5 gigahertz monster CPU, 3, 4, 5 years before those things came out. Whereas if you're just a ticket selling company for a local tourist attraction and you're somehow able to hoodwink the tourist attraction into using you, maybe that market pressure isn't there.
Yeah.
Especially because at that point, you've already bought the tickets. So what are you going to do?
Yeah. I guess it would be a shame not to go. Maybe that it convinces people to actually go. They're like, well, I spent 20 minutes of my life getting this ticket. I sure as hell am going to go.
Quite possibly. So performance as a measure of, I guess, what you're using, I'm not quite sure how, relevant that is. I know that a lot of people nowadays complain about software bloat, that everything runs on Electron, or that everything has to...
really throwing Electron under the bus there, but
people were even complaining that things ran on the JVM back in the day, and the JVM is fast. Like, I think that things that run on the JVM are good, in my opinion. I'd honestly rather be running Java code than C code, because Java code's probably more secure. So,
I mean, I think that depends on who's making it.
Well, there are some memory-related things that the JVM guarantee. Like, you're not going to run into a basic stack smash in a JVM application. That's my point.
Maybe it's not less secure. Maybe you can just blame it on someone else. Then it's not your problem.
There you go. Perfect. Point is, it will guard you from the worst cases of that. And
absolutely.
And I think
those Oracle lawyers have got a little more say than you.
Oracle has some good developers. It has some good developers. I'm not an Oracle stan by any means. I know what they do, but they're competent. They write good things.
Yeah.
Sometimes.
I mean, obviously, they've been in the industry for a while. At the very least, that's got to give them experience to write decent things.
Like, they have done things that I would not expect another company to have been able to do. Let's put it that way. Their engineers are very talented.
Yeah, absolutely.
But I think a lot of this is just reflective of the fact that the Pareto principle is very alive and well in code, and it's kind of why you have so much of focus on Python for these really high performance applications of programming now. Like, you have, I think CUDA just came out, and Python is like the slowest language ever. Like, I think that Emacs Lisp is faster nowadays. That used to be the slowest. And it's paired with something that is solely made to speed up doing math really, really, really quickly, like CUDA. So it just kind of shows that as long as you write the hot parts in something that's relatively fast, then it doesn't really matter how many layers you have.
Yeah, I think that one of the big things that really drives performance down is the fact that everyone wants their stuff to work on everything, right? So then you have to consider portability. And whenever you have to consider portability, then it just makes it so much harder to consider, the details of what you're running it on. So you just have to focus on everything. So you miss out on loads of optimizations, and you don't have to rewrite your code. You're getting that back. So I think it's at least a bit of a trade-off between portability and performance, obviously. And I think obviously you want a website to work on everything, So.
Yeah, precisely. And that actually kind of reminds me of this talk from Gary Bernhardt called The Birth and Death of JavaScript, where he predicts in the future that everything will just be running JavaScript as its metal language, and there's going to be no operating system kernels with context switching. Everything's going to run in, I think, user mode. And because you don't have to deal with the MMU and context switching anymore, the VM protects your memory. So whatever you lose from running everything in JavaScript, you gain from not having to context switch anymore, which I thought was quite funny.
That sounds wrong, but he probably knows more than me. So maybe that.
It's a very satirical talk. But
okay.
I'm sure there's multitudes of reasons that wouldn't work. But
that's hilarious.
It does make you think. And there are benchmarks where you can cherry pick where C and bare metal languages, especially that have access to hardware acceleration, are just going to crush anything else, regardless of what that language is or what that VM does. Because if you don't have access to AVX, if you don't have access to a GPU, then you're going to lose for a huge number of benchmarks. But just for your average application, I mean, JavaScript is only how many times slower than C? 3, 4, 5 times slower nowadays?
Yeah.
If you're writing it in a not disgusting way.
And everything is Java now. Oh, wait, Java.
Yeah, and Java's not even that much slower than C. That's maybe 1.5 to 1.2 times slower, depending on what you're doing.
Yeah. Though it's not really just C code in general. I think what makes C fast is not C itself. It's that you have the control over C that allows you to do those optimizations.
Mm-hmm.
I don't know. I took a class on like, optimizing performance and stuff like that. And you just, I don't know, turning on like telling the compiler that you're only running on this CPU so it can like go ham with like, certain optimizations, just like the optimization part is like a lot of it, like just rewriting the order of instructions. Sometimes you can like eke out, I don't know, like you can like double your performance because you don't have to worry about like running into like memory bottlenecks. Obviously you still will, like everything's memory bottleneck, but like, you can feed that CPU pretty well.
Mm-hmm.
So
and I mean, like regular JITs nowadays can do that too, though. I mean, the JVM is not within 20% of C because it is just magical. It also does a lot of those optimizations, and a lot of the reason that JavaScript is that fast is because V8 and SpiderMonkey also do that. It's just that their data structures are not like perfect one-to-one mappings of how CPUs and memory work.
No, that's not what I'm saying. What I'm saying is specifically, I think it's the programmer who makes those optimizations. I don't think C is inherently fast unless you make it fast. Like, it takes thought, it takes effort. It's not just, oh, I turn on O3 optimizations and everything works out great. Oh, good job, me. I remembered one compiler flag. Like, it takes a lot of effort and you can eke out a lot of performance sometimes. Like sometimes you're like, what am I doing with the, I'm doing all of the additions and then all the multiplications when I could be doing them simultaneously. Like get those pipelines filled and you're like, oh wow, this like doubled my performance in my program. Like I think it takes a lot of effort to optimize. And I think that's where a lot of the lack of like performant software is just like people don't put in the damn effort for, maybe they can't, but like oftentimes I think people are just lazy.
Well, that brings up a good point. Is it laziness or is it just writing better software? Because better is a very, loaded word. It can mean a lot of different things to a lot of different people. But in C, it's very difficult to accidentally copy something, right? You have to call memcopy or you have to, with an int, you can just reassign it, I guess. But that's not really copying. Whereas with a functional language like Haskell or Clojure or, any kind of functional language or any kind of functional library on like a non-functional language, like C#'s immutable collections library, you can copy things just so many times per function and not even realize it. Dude. Like, especially if the library is not programmed well.
Yeah, your memory stack's like just giant.
Yeah, precisely. So,
talking about a memory bottleneck.
Yeah, and like every like function that you call is effectively doing a memcopy, which, a lot of functional languages try to work around that. Clojure does a pretty good job of it. Especially with like those kinds of like just flat data copy it kinds of libraries, you just don't realize how bad it can get. But does that make the program worse? That's the question. Because it does make it, slower, but perhaps it can improve program quality so drastically in other ways that it is more than worth it, and we should all just be happy that we have the ability to run these incredibly bloated and slow programs now.
I guess that's one way of looking at it.
Is that take hot enough for you?
I think it's a little too hot. I guess I disagree, but I guess in the sense, C, the advantage of C, when you put it that way, is not that it is fast, it's that it forces you to consider details that you don't want to think about for, I guess, whether that's good or bad. So you do have to think about copying memory. It's just that it's not a luxury in C for you to not think about that. So I guess in a way, I agree with you that the reason why C is faster is because you have to think about those things rather than just waving your hands up in the air and being like, oh, well, I hope this goes fast in the language I'm writing it in. And if not, oh, well.
Mm-hmm. So let me explain my take a little bit. So I'm not saying that slow software is good, not at all. But what I am saying is that the means of architecting software that involves this very low level of fiddling around and mutating all these different variables, that makes software so impossible to test, to debug, to audit. And you really just can't guarantee the behavior of a sufficiently large program when it's written in such a way. Whereas if you do it in a means where your state is, all of your state transitions are thoroughly auditable because you effectively just do this very functional way of thinking about the data flow throughout your application. So let's say that you just have, your application just models a state machine and then everything is derived from that state machine. And therefore everything is very testable because it's effectively just a bunch of pure functions and then like maybe one function that just overwrites that state machine state. And therefore, everything is much more testable. You can audit how an app got into a certain state, so that way you can prevent it from reaching a state that you don't want it to reach for some reason.
Yeah.
And your app is significantly less likely to break on a client's machine because of that, because it's much more understandable from a high level by the humans that wrote it, and also potentially by the computers that are running it if you want to put type checks on it, because, you know, some of the most advanced type systems, TypeScript and Scala sort of notwithstanding, are on these really arcane functional languages like Coq and Idris, because as it turns out, if you just model everything as lambda calculus, it's just relatively easy to math that out in a theorem prover.
Yeah. Yeah, I guess that's definitely true. Yeah, if there's anything I've learned in C and C++ is that a lot of things are just undefined behavior, which means that you can do a lot of things that you probably shouldn't. Whereas in, more modern languages, they usually lock that junk down. They're like, no, you can't do that. You can't read uninitialized memory. No, get out of here. Go away.
And I think that the price of recomputing things and doing things in this not very efficient way and, making everything a hash map instead of an offset struct, just because it's easier to understand and simpler from an app design perspective to think of something as maps and lists rather than, like 128 bytes of data that somehow represents a date time. It's really freeing in that sense. And I would like to just bring up that, back then when you did have these Commodore 64s and your ZX Spectrums and stuff like that, if your program crashed, you could very well just, ruin your entire session. Or even like thinking back to older versions of Windows, like if a driver did not work, then blue screen, right? Or if a program didn't work on, some low quality kernel, you get a kernel dump or something like that. And then like 15 years ago, we were in UI toolkit hell and nobody enjoyed that. Nobody wanted to continue writing swing code for the rest of their lives, I'm sure. Nobody really wanted to continue writing Win32. And now we're at React and it seems like everybody is reasonably sated. So,
yeah.
And I think that over that amount of time, our apps have also gotten significantly less buggy.
No. I don't think they've got significantly less buggy.
Well, have they gotten... Okay, well, there may be a similar absolute number of bugs, but I think that our apps have actually gotten so much larger that there's less bugs per line of code if you're doing it right now, if that makes sense. Because you can write a whole bunch of really subtle memory corruption bugs in C where you're just never gonna, it may even not be detected for the lifetime of the program, but they're in there and they can cause problems if you do something very arcane.
Okay, let me say it this way. I think the number of dramatic bugs have gone down, whereas I think the number of maybe what I would think of a softer bug, I guess, has gone up significantly.
So what would be a good example of a softer bug? I feel like bugs have
become more gray. You know what I'm saying? I feel like in modern day, there's a lot of programs and then you're like, oh, what does this do? And people are like, oh, don't use that. That's bugged and has always been bugged since the creation of this program. And you're like, okay. And they're like, yeah, we found ways around it though. So don't worry. And you're like, all right. Whereas in ye olden times, like you said, if a graphics driver screwed up, your entire computer went down. So I guess, people were, more inclined to avoid bugs than they are nowadays, which, as you said, could arguably be a good thing because obviously, taking down your entire computer for something relatively minor might be a bit of an overreaction. But
I'd like to bring up a counterpoint, though. Video games are still coded in that kind of old, C++, some of them using ECS, but a lot of them are still coded in this old C++ mindset in a very similar way to that which they were coded maybe 10 years ago. And I think we've seen more bugs in those large heaps of C++ code per feature than we are starting to see in a lot of other applications, if that makes sense.
That's a really bad example because before it was just pixel art and sprites, whereas nowadays it's an entire damn city and they're trying to get it out in roughly the same time it took to get 12 people in their garage to make a 2D game.
Okay, that's fair. I think they may have expanded in scope a little bit more than other applications. That's possible.
They're always trying to promise the moon. Anyway, yeah. But yeah, so I guess the gaming industry is probably not. Do you have any examples, I guess, in a more stable developing environment?
Anything that's not 3D, you mean?
I guess so.
There's still a lot of I guess this kind of depends on how you think about the time that people put into their applications, but there's still a lot of bugs in C-based GNOME applications that I use that are just weird UI stuff that just doesn't really fit right. Whereas, let's say you use something I don't know, let's go for lower rent here, Mattermost or something, the Slack replacement. There's not that, the UI is a little bit, old and todgy the last time that I used it, but it's not, buggy. It works most of the time.
No, I feel you. Okay, yeah, that's
Whereas, if I boot up, this is a bad example because it's not buggy, but, if I boot up an application like Rhythmbox, there's probably going to be some weirdness in there just because it's kind of always been that way. Yeah. Or if I boot up Audacity still crashes all the time. Or if I boot up GIMP or Inkscape, those applications, they're old, but that kind of proves my point, right? They're old pieces of C code that are kind of buggy, whereas, most newer style applications that were not written to run on a 386 generally are a little bit higher quality from what I've seen, just in terms of not crashing, not having as much UI jank. They may have fewer features, but what the features that they do have are significantly less likely to crash your graphics driver.
Yeah, I guess so. Yeah, and no, you're probably right.
I guess we are lucky to be able to run all of this bloated junk. Maybe this bloated junk is good.
I still want to say no, but I think you're right in some sense. I think some things have definitely gotten better. I think it's too much though, because I feel like it's starting to outstrip the amount of performance gain we're getting with hardware, honestly. Websites.
This is true. Hardware has kind of stagnated recently, though, so that might be part of it.
I don't think you're are you going to need a high-end graphics card just to run websites in the future? Is that we're going to have to figure out how to parallelize website rendering? Is that going to be a thing?
Well, that's kind of what browsers have done, is they've at least moved it onto multiple cores, and they're trying to move it onto graphics cards, albeit, in my opinion, with mixed success. But those are runnable on old graphics cards. I have a really, really old integrated graphics card in my machine, and it's not being fully used.
Yeah, and I guess that is part of the reason why it's the bloat has outstripped the hardware, is because a lot of single-threaded improvements are not really where modern processors are excelling at. Obviously, they run into harder limitations, so now multi-threading is becoming a bigger focus. So if you're not...
Since 2015, we've had maybe a 20% improvement in single-threaded performance for 6 years now.
Yeah,
that's not
so I guess
a lot.
If you ignore all of those improvements, obviously, I guess you are probably pretty quickly going to outstrip your the amount of resources that you might have been trying to use. Yeah.
Mm-hmm. And there are still frontiers of increased programmer ease that we are going to probably try to conquer one day. We may want to bring back symbolic logic programming as a data structure replacement, or a data structures and algorithms kind of replacement, because you can write programs that are significantly simpler and more declarative by tossing them into a logic engine, but of course that logic engine is incredibly slow, maybe 10,000 times slower than if you had just implemented it by hand. So it's possible that we could see, continued drive towards slowness, but I think right now where we are, and this might age poorly, but I think that we're kind of at the point where we've reached kind of a happy medium, and I think that we might remain there for some time, if that makes sense. We've reached the point where everything's a hash table. We've reached the point where everything is dynamically typed and rendered to some kind of somewhat GPU accelerated, somewhat DOM-like kind of structure.
I don't like it because I feel like the more abstract, more layers of abstraction you get, the more people just don't understand certain things. If you don't know what's really going on with your data structure, you're just oh, it's a hash map or something like that. And then you don't understand why it's not performing the way you think it might. Then you kind of just avoid using it in that way. And you might come up with something really jank. And then with a new layer of abstraction, something might get built on top of that jank, which then might cause more jank. There's just layers upon layers of jank. And like, obviously don't go overboard, but if you try to use like the most performant tool that you can reasonably write like the program you need to in that amount of time, like, you know, obviously if it's something that needs a lot of time, like, I don't know, you're writing a driver and it needs to work perfectly or something like that, you know, use C. And, you know, don't use C for something that obviously you need to get out there really quick. But if you try to write as low level as you can like reasonably get away with, you are then forced to think about things and then can avoid some of that jank because you actually know what's going on under the hood.
That kind of sounds like you're trying to reinvent the wheel, though, without the expertise of all that we have gained with the wheel, if that makes sense. All that we've learned about wheels. Because your wheel might just be like a copper plate, whereas we might have already designed a Formula One wheel that is made out of carbon fiber and will run better than your solution.
Why?
And even though you have layers upon layers on top of that F1 wheel, it still might not be... You might be able to increase the quality of your program significantly without taking a large performance hit, just because you may not have read up on the latest paper on a certain data structure that works well for this algorithm that you're trying to implement.
Oh, you're saying that things need to be as complex as they are nowadays.
Well, I'm saying if your suggestion is to go back and reinvent the hash map because you don't understand how the hash map works, which I don't think we're ever going to reach that point because hash maps are like the first thing you learn in school.
No. Yeah, fair enough.
Then you're likely going to miss out on all of those progressive optimizations that we've made to hash maps, like different chaining algorithms and really, really, really fast hashing algorithms that have really good uniformity. You might try to just roll your own, which is going to be, you know, maybe 2, 3, 4, 5, 6 times slower than the best.
Yeah, but I guess, but once again, I don't think most of like the performance issues are with, I guess, the algorithms that people are using or anything like that. I think most of the performance is just that people aren't putting in the effort to consider what might be a better solution. Like most of these performance things aren't free. Like, you know, like they've come up with like ways of doing things, but often they're like special cases of other things. You can't just, I don't know, like trust the compiler is going to do everything for you because it doesn't. Like, you know, like whatever system you're using, you might convince yourself that there's no way that you could do it faster than the people who put in all the effort to do that thing, but they're making a general purpose thing and they might put in optimizations, but it's not able to understand your intent. It's not magic. It just goes with the best guess it can. And sometimes the best guess is a general solution. And sometimes your solution might not be anywhere close to the general solution. Like
that comes back to the fact that 5% of the code takes up some ridiculous percentage of the execution time. Maybe like, you know, 5% of the code takes up 90% of the execution time, then why bother dropping down for the whole thing when you can just, maybe you can even just optimize that 5% enough in your host language or in your host framework or library stack that it's fine. And then by dropping down, you've just lost so much that you could have gained by that.
Yeah, you might be right. It might have like next to nothing to do with the language choice. I guess my thing is just put in more effort into your program. That might be stupid, but like, you know, unless you're doing game development, you've got a pretty cushy job. Like, you know, things aren't that hard for you. You can sit down for another 5 minutes and decide whether this might be the best solution. Try maybe like another solution that just takes like 2 lines of code to edit. And if that doesn't work, just revert it back. Like, you know, you've lost 2 minutes of your life. Your boss isn't going to notice a massive performance drop in your coding abilities. Like, in fact, you might catch bugs that you wouldn't have like considered before or something like that. Like, even though you might think you're done, just like, you know, be like, am I actually done? Is this good?
I think that there is something to do with language choice. If it intersects with a certain bad, like you can have problems with your language choice if you're picking like a monstrously terrible language to hardware intersection. Like I would never want to run Python or JavaScript on an A53 octa-core because, you know, A53s are dog slow and 8 A53s next to each other are not going to be any less dog slow when they're running Python or JavaScript.
Yeah. To a reasonable degree, as long as you make a reasonable choice in your language. You know, don't write websites in C and don't write 3D game code in Python because, you know, like you could write a website in C, but, you know, that'll probably take 12 years of your life.
And also you can't just because the browser won't let you.
Yeah. And I guess you can.
You can write it in, well, I guess you can write it in C that compiles to WebAssembly, but that's not like real C, if that makes sense.
Yeah, that's just as real C.
It's still running on a VM.
Yeah, but that C doesn't care.
Well, yeah, but you're not running directly on the hardware still, so you're
I don't think C cares about that. But anyway, yeah.
Well, C doesn't care, but the point is that it's not like
even in the best case scenario, you're not even eking out that much additional performance. And if in Python, I think you literally can't. Even writing stuff in C, there are just limitations that you can't do. You know, you can't be like, oh, I'm gonna load this entire world into memory. It's like, no, you only got, 8 gigs on certain computers. So no, you cannot load an entire world into memory, no matter what language you're writing it in. There's just things you can't do. Yeah.
And that's the show. Thanks to Meydän, that's Meyda with an umlaut N, for their track The Beauty of Maths, licensed under the Creative Commons Attribution 3.0 license, which serves as our intro, outro, and interlude music. You can find more in the description of this episode. Please remember that the opinions expressed in this production may not reflect those of other participants on the show, or those of any participant's past, current, or future employers. They're also probably exaggerated a bit for comedy's sake. Anyway, thanks for tuning in.